I'll do an example where I won't skip 5. How about that? How about, nitrogen. Now, who goes in the middle? If I only have
No
two
one?
atoms, does it really matter who I call the middle? And actually, if they're the same atom, technically, I think of them as sharing the middle. So actually, step 1 doesn't really matter for this one. Okay. So I'm going to put in valence electrons. I probably should be doing this one in pencil. Watch why you want to do this in pencil now. How many valence electrons should nitrogen atoms have? I'm going to put in valence electrons and make obvious bonds. How many valence electrons for nitrogen?
3.
Well, no, that's the number of bonds.
5.
It's 5, right? Okay. So, all right, I'm going to give each of them 5. Right? And then I'm going to make an obvious bond, like yeah. So now I want to check octets. I'm going to look at this nitrogen. How many electrons does this nitrogen have, including sharing? Someone said 6. That's correct. 1, 2, 3, 4, and then 2 in the bond. So 6. And this nitrogen also has 6. So I haven't made the octets. Maybe I counted wrong. Let's check the total valence electrons. I have 2 nitrogens. They each have 5. So I should have 10 electrons in the total. 10 electrons valence. So how many do I have in the structure? To me, it looks like 10. If I look, each nitrogen has 4 dots. That's 8 dots. And then there's a stick in the middle, which makes 10. So, I can't add any and I can't take any away, and my octets are not satisfied. So now I'm going to invoke step 5. I'm going to repeat steps 2 to 4 if necessary, which means I need to make more bonds. Yeah? Okay, so what I'm going to do is I'm going to take an electron here and take an electron here and put them in the middle. Yeah? And make a bond. So then my structure becomes like this. Yeah. Now it's not an ion. I don't have to bracket. Let's go back. So check octets. Now in this structure, how many electrons on this nitrogen?
5.
Wait a minute. How much does each stick count as?
Oh, wait, never mind.
It's 7.
4.
Yeah, so each stick counts as 2. So the two sticks in the middle count as 4, 5, 6, 7. So this nitrogen has 7, that nitrogen has 7. So I still haven't done it right. Well, what total valence? Do I have 10 in this structure? It looks like I see 6 dots and 2 sticks. That's 10. So I can't add any, I can't take any away. I have to repeat step 5 again. So now I'm gonna take this one and that one. And I'm going to put them in the middle. Okay? Now I'm going to get, is it legal to do that? I have 3 sticks. Is that okay? My good idea says I can have a maximum of 3 bonds. Okay, so now, how much does each nitrogen count as having now?
8.
So yeah, this one has 8 and that one has 8. They're sharing 6 and they each have 2 by themselves, right? And if I look, this should be 10 electrons. There's 4 dots and there's 3 sticks. So that's 10. So now I've made my condition. Okay, so there's a cleanup step actually. Is this structure okay? Or could I make it a little nicer? Does anyone
nicer?
Yeah, what could I do to it? What would make it nicer? Someone see what I see? What's wrong with it? It's making me miserable. I can't stand it anymore.
Can't you make the electrons like
pair
2 on the left side and 2 on the right?
Yeah, I'm going to pair those electrons. That's a cleanup. Pair. Right? Does that make sense? Okay, and now I'm done. Check. Raise your flag, declare victory, go to the next one, America. All
Wait,
right,
so what's the final Lewis structure look like?
that's it right there. Each nitrogen now has 8 electrons, and I have a total of 10 electrons in the structure. All the electrons are paired. I haven't violated any good ideas or, and I've gone through my steps. So by the way, the pairs could, the pairs could be usually anyway. I could have a pair down and a pair up if I want. It doesn't have to be right and left. And let me go back to water for a sec. When we did water was like this, right? Now, I could have just as easily made water like this. And this would also be okay. These two structures are equivalent. Let me move it over. So neither one of these structures is the shape of water. The information in a Lewis structure is how many lone pairs on which atoms and how many bonds between who and whom. Yeah? And that's it. So we're not going to talk, we'll talk about the shape after spring break. Yeah? Yeah, so someone said, does it matter which dot we move to the middle? Yeah, I mean, what I did this on purpose, but what I would have done instead of doing this is I would have taken these outside dots and moved them in the middle. And then I would have had a structure that was like this, right? And I'd be done. You can be selective. At the end of the day, it doesn't matter which dots you move to the middle as long as you clean it up and pair it. Okay?
Professor, I got another question for you.
All right.
So for H2O, does it matter about the arrangement of the H molecules?
Yeah, so what I'm saying is this one or this one are both valid answers.
Okay, perfect.
Because all you've done is you've met the octets and you've met the total valence. That's all you have to do.
Okay.
In general, unless you're forced to, Lewis structures are generally, the constituents of Lewis structure, I generally put up, down, right, and left.
Okay.
And so for this class, we don't have to violate that. If you have an expanded octet, like if I had 5 atoms attached to a central atom, then I can't do that strategy. I have to do like a pentagon or something, or a star. Yeah. But in general, notice how the pairs are either going to be right, left, up, or down. The bonds are going to be right, left, up, or down.